Sorry about that. The bell had just rung in the middle of that last video. So here's the end of this problem. It would be 1 over 81 minus, now when you square 4 times the square root of 5, you need to do 4 squared times the square root of 5 squared. And square the denominator also. Now that they have a common denominator, we can subtract to get our final answer. So that's 1 over 81 minus 80 over 81, which is negative 79 over 81. The other half of today's lesson are half-angle formulas. So we just talked about the double angle formulas. Now we need to talk about the half-angle formulas. What we're going to do is take the double angle formula and we're going to solve it for cosine theta. When we solve it for cosine theta, we would add 1 to both sides and then divide both sides by 2. And then take the square root. And remember, when you take the square root, you'd have the plus or minus with it. So when we do that, we get cosine equals plus or minus the square root of 1 plus cosine 2 theta all over 2. That formula is going to be the half-angle formula. The way it's going to be a half-angle formula is I'm going to replace theta with theta over 2. I'm going to divide it in half. And if I divide that in half, I need to divide this one in half also, and I just get a theta. So the half-angle formula for cosine is the cosine of theta over 2 equals plus or minus the square root of 1 plus the cosine of theta over 2. The plus or minus is going to depend on which quadrant you're in, whether or not your answer is positive or if it's negative. This is one of those formulas that you do need to have memorized for your formulas quiz, which will be the day before the Chapter 7 test. Actually, sorry, scratch that. You don't need to have this one memorized. I forget. This one you don't need to have memorized, so never mind. Sorry. We're doing the same thing with this formula. And we're going to solve it for sine of theta to get the half-angle formula for sine. It works out like that. Again, to make it the half-angle formula, we'll cut those angles in half, and we'll say the sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. People get kind of confused because they're saying, well, this is the sine formula. Why does it have a cosine in it? It just does. It's because we were starting with this double angle formula for cosine as we were figuring it out. That's why there's a cosine in it. So we have a half-angle formula for cosine. We have a half-angle formula for sine. Now we need a half-angle formula for tangent. And for tangent, what we're going to do is say tangent is sine over cosine. Then we're going to substitute all of this stuff from sine in right there. Substitute all of this stuff from cosine down here. And then to get rid of the square root on the bottom, we would rationalize, so we would multiply by this square root right here on the top and on the bottom, and it simplifies to this. This is another formula that you don't need to have memorized, so I'm just kind of showing you in general terms where the formula comes from. What's important is being able to use the formula once you're given the formula. So in summary, these are the 3 formulas that you should have written down from this part of this section. The 3 half-angle formulas for sine, for cosine, and for tangent. In each case, there's a plus or minus out front, and in each case, we're going to decide whether we're using the plus or minus based on which quadrant we're in. Some examples on how to use those formulas to figure things out. Use a half-angle identity to find the exact value of each function. The sine of 7 pi over 12. If you really wanted to, you could change that into degrees and work in degrees. I'm going to stay in radians. I'm going to rewrite that as the sine of something divided by 2. 7 pi over 12 is the same as 7 pi over 6 divided by 2. Take a minute to think about that math. 7 pi over 6 divided by 2 would be the same as 7 pi over 6 times 1/2. Yep, that is 7 pi over 12. So now I'll use my half-angle formula for sine, and this is my x value, or my theta value, that's going to go into the formula. The half-angle formula for sine was plus or minus the square root of 1 minus the cosine of that angle, so the cosine of 7 pi over 6, all over 2. Let's start with deciding the plus or minus here out front. 7 pi over 12. Which quadrant is 7 pi over 12 in? Well, this would be 12 pi over 12. So this would be 6 pi over 12. That means 7 pi over 12 is over here somewhere. So we're in the second quadrant. All students take calculus. In the second quadrant, sine is positive. So we are going to use just the positive here. So it is the positive square root of 1 minus. We've got to figure out what is the cosine of 7 pi over 6. 7 pi over 6, this is 6 pi over 6. So 7 pi over 6 is right here. The reference angle is pi over 6, or 30 degrees. So I can draw a 30, 60, 90 right triangle. The cosine of 30 degrees is square root of 3 over 2. And this angle was in the third quadrant. In the third quadrant, cosine is negative. So it's actually going to turn into a plus. When you're minusing a negative, that's a plus. That's still all over 2. We need to simplify this. There are lots of right ways to simplify it. What I'm going to do is get a common denominator up here on the top and call it the square root of 2 plus the square root of 3 over 2. My common denominator was 2 over 2 here for this one. And that's still all over 2. To get rid of the fraction in a fraction, I'll multiply by the reciprocal of the denominator, and I'll get the square root of 2 plus the square root of 3 over 4. The tricky thing about this section is that your answer in the back of the book might not match your answer because there are multiple correct ways to simplify these. Just make sure, if you want to check your work, go back to the beginning, put your calculator in radian mode, and type in the sine of 7 pi over 12, and look at what decimal you get. Then type in your answer, look at what decimal you get, and if they're the same thing, you did it right. If they're not the same thing, then you messed up. Another example using half-angle formula. Figure out the cosine of 67.5 degrees. Since we're supposed to use a half-angle formula, I'm going to rewrite that as something divided by 2. 67.5 is 135 divided by 2. So 135 is going to be the value I plug in to the formula. The half-angle formula for cosine was plus or minus the square root of 1 plus the cosine of our angle divided by 2. (135° is here. The reference angle for 135 is 45 degrees. So I need to draw a 45, 45, 90 right triangle and find out that the cosine is 1 over square root of 2 or square root of 2 over 2. Before I forget, I should probably decide if I'm going to be positive or negative. So I'll look back at the original, 67.5 degrees. That's in the first quadrant. In the first quadrant, everything is positive. So my answer is going to be positive, square root of 1 plus root 2 over 2 over 2. I'm going to simplify this one pretty much the same way I did before. I'll get a common denominator on the top and make that all one fraction. I'll get rid of the fraction in a fraction by multiplying by the reciprocal. To get my simplified answer. An example like that with tangent, figure out the tangent of 15 degrees using a half-angle formula. So we would rewrite it as the tangent of something divided by 2. We're going to rewrite it as 30 divided by 2. At this point, you might be thinking, didn't we do things like this yesterday? Didn't we write 15 as 45 minus 30 and then use the sum and difference formulas? Yes, you could do that. The directions here specifically asked us to use a half-angle formula, so that's what we're going to do. Same thing on your homework. On your homework, there would be other ways to do it, but the directions are going to say use the half-angle formula, so that's what I'd like you to do. The formula for half angle of tangent is plus or minus the square root of 1 minus the cosine of 30 over 1 plus the cosine of 30. We'll decide on the plus or minus based on the angle in the problem, those 15 degrees. 15 degrees is in the first quadrant. Everything's positive in the first quadrant. So we know we have a positive answer. Now we've got to figure out the cosine of 30 by drawing our special right triangle. Cosine adjacent over hypotenuse is square root of 3 over 2. All right, with a problem like this, there are multiple ways to simplify it. And with those multiple ways to simplify it, you're going to get slightly different but equivalent right answers. One way to simplify it would be to get a common denominator on the top, a common denominator on the bottom, make them all one fraction, then flip and multiply. The problem with that, so I'm not going to do it this way. I wouldn't write this down if I were you. Just real quick, I'd get one fraction, I'd flip and multiply. Now when I flip and multiply, the 2's are going to cancel out, which is kind of nice, but I get 2 minus the square root of 3 over 2 plus the square root of 3. And all of this is still in a square root. The problem with this is now I'm going to have to multiply by the conjugate to get rid of that. Now this would work. This would totally be fine. You would get full credit for it. I'm saying this is not the best way to go because there's all these extra steps. You have to get common denominator, get common denominator, flip and multiply, multiply by conjugate, multiply by conjugate. Lots of things to do. So instead of doing that, here's what I'm going to do. This is where we were. Instead of going through the process of getting a common denominator and flipping and multiplying, I'm going to just start right off by multiplying by the conjugate. The conjugate here is 1 minus square root of 3 over 2. 1 minus square root of 3 over 2. It's going to save me a little bit of work in the long run. Both answers would be correct. They'd actually look different, which is kind of strange, but they would both be equivalent. They would both get full credit. I think this way is easier. Now we need to FOIL out the top and FOIL out the bottom. On the top, we would get 1 minus square root of 3 over 2, another minus 3 square root of 2, so I'm just going to say we have 2 copies of square root of 3 over 2. And then when we do the last, it would be plus square root of 3 times square root of 3 is 3. 2 times 2 is 4. On the bottom of the fraction, we're multiplying conjugates. We like multiplying conjugates because we know the outsides and the insides cancel out. So we're just going to have 1. The negative square root of 3 over 2 and the positive square root of 3 over 2 would cancel out. So we just have to do the lasts, which are minus 3/4. Combining some like terms, the top turns into 7/4 minus the square root of 3. The bottom turns into 1/4. Here's where I'll flip and multiply, and it's a very easy number to multiply. Just multiplying the top by 4, and I get my simplified answer of 7 minus 4 square root 3. Your homework, verify one, and then your homework. Sorry about that. A verify problem, and then homework in this section. Verify that the cosine of 2 theta over 1 plus the sine of 2 theta equals cotangent theta minus 1 over cotangent plus 1. There are lots of correct ways to start this one. What I'm going to do to start is I'm going to work on the right-hand side and change everything to sines and cosines. Then it would be a good idea to make all one fraction on the top and all one fraction on the bottom to get a common denominator to do that. So I'm going to change 1 into sine over sine and sine over sine here. So as all one fraction, the top would be cosine minus sine over sine. And the bottom would be cosine plus sine over sine. To get rid of the fraction within a fraction, I'm going to flip and multiply. So I'd be multiplying by sine over cosine plus sine, sine over cosine plus sine, a little shorthand. That's going to clear out this fraction. The sines are going to cancel, and I'm going to be left with cosine minus sine over cosine plus sine. At this point, I'm not exactly sure what would be the best thing to do next. So, to get some help, I'm going to look at the other side and see where am I trying to go and see if that can help me figure out what to do next. On the other side, I have cosine 2 theta, and that's one of our formulas. Cosine 2 theta is cosine squared minus sine squared. And on the bottom, it's 1 plus sine 2 theta. There's a formula for that. That was 2 cosine sine. So looking at that, that might be a hint of what I would want to do next. The top that I'm trying to get to is cosine squared minus sine squared. The top that I have is just cosine minus sine. This that I'm going to is difference of squares, and difference of squares factors into cosine minus sine times cosine plus sine. So it looks like multiplying by the conjugate would help me get to where I'm going. So that's what I'm going to do. I'm going to multiply the top and the bottom of this fraction by cosine plus sine. I'm multiplying by that because I'm looking at where I'm going and I'm saying, okay, that's going to be the step I need to do to get the tops to match. Hopefully it will also be helpful in getting the bottoms to match. Foiling that all out, on the top, multiplying conjugates, we know that it's just going to be cosine squared minus sine squared, and that the middle terms would cancel out. On the bottom, when you FOIL it out, you get cosine squared. You get cosine times sine, and another cosine times sine. So you get 2 copies of cosine times sine. And you get a sine squared. This is good. Now the tops match what we are trying to get them to be. The bottoms have the 2 cosine sine that we want. And these 2 terms could combine using a Pythagorean identity to equal 1. So this is good. We've got cosine squared theta minus sine squared theta over 1 plus 2 cosine theta sine theta. Then we'll use our double angle formulas and say, okay, we know that that top part is the formula, and that's what cosine 2 theta equals. And on the bottom, we'll use the other formula and say, okay, we know that's what the sine of 2 theta equals, and now we're set.